Hello guys, this is the first video in animation versus wizard skeleton, and here we will make this little moving stick figure. He can move, jump of platforms. We will be using Raylib for making the code basically for this guy, so you can get Raylib from raylib.com. I will leave a link in the description. I want to be exactly teaching Raylib here, but I will be more like showcasing it, so it is recommended if you have some basic knowledge on Raylib before watching. I will also use Pivot Animator to animate the stickman figure. If you are like following along and wanted to animate it, I would really recommend if you can animate the stick figure yourself because this makes the game development more fun. But if you just want to use the stick animation I made, I will leave a link in the description. Without further ado, let's get started by animating our character. Okay, it looks like a jellyfish is swimming or something, but Alan, so this is gonna kill me. Okay, that's good enough for me. Let's save animation first. Idle. And now we are gonna edit it. So now I wanna. So let's export as GIF as well. Orange-run.gif. Do I need something else? Oh yeah, we need the jump. So let's make this as well. Is this how we jump? Because I honestly don't know. This looks so weird. I don't think this is how normal people jump at all, but okay. I'm happy with how it ended up looking. Let's pum. I wanted to make it like look like he's smashing the ground or something, but it ended up looking as if he's falling over something or like dribbling. But whatever, orange dash jump and let's export the animated GIF out. Orange jump. Yep, perfect. Now for our second stage. Still recording, good. Okay, we are okay, and I'm finally done making all of the animations. Orange jump, orange idle, orange run. We need to convert those GIFs to sprite sheet. So GIF to sprite sheet converter. This one looks good, and let's start uploading our stuff. Start by idle. Let's try 6 columns. Convert. Nope, it's 7. Convert. Perfect. Let's save. This PNG looks good. This is still not the final thing, by the way. we still need to collect the spreadsheet together, but so far so good. Let me orange. Yeah, Jeff switch. I'm going to uninstall, to be honest. This is idle. Now we will make the jump. No. Let's make the jump. I think I made this like 11 or so. It's like I overdid it, sadly. No, it's 12, yeah. Save, run. Or no, this is jump. Okay, and orange dash run.gif. Again, I have to get back and upload. It's actually 6, so let's make it save. Run. Yeah, we have those 3. Idle, jump, run. Now we need to spreadsheet packer. Spreadsheet packer. I need to save as well my game dev assets, and the other one needs to be saved in my game dev, not coding. Game dev. There we go. So we can import them like so. Clear everything, and can I import them all at once? Perfect. I just want this is idle. Hold on. I want the idle first, then run, then jump. Hold on. This is idle. This is run. This is jump. The jump gets added. Idle. I want the idle to be after run. We have jump. God, this is annoying. Let's add it like so. Idle and jump finally. I'm not even sure why it does this. Animation wizard output orange. I want to add idle first. We want to no. We add idle first, then add run, then add jump. Why? Don't get. Whatever. Okay, let's just download as PNG. Sprite orange.png. Okay, perfect. Finally we have it. So let's go on and import it to our Visual Studio. Also, in case you don't know how to use Raylib with Visual Studio Code, you can basically go to the link or leave in the description. It's a Visual Studio Code template for Raylib made by gamedev.tv, so thanks a lot for them. You need to get those files in your Visual Studio Code folder, so you can like press on code and you can download the zip and extract it, or you can be a cool guy and clone with HTTPS, which I will be doing. So we'll get back here, go to the terminal and do get clone and then paste in the link. I'll put a dot so it clones it to my current directory. Again, if you don't have get or you don't know how to do this, just download it as zip and extract it in the folder you're working with. Okay, so you should end up with those files. Press on main.code-workspace, open workspace, and you're ready to go. So you can make your main.cpp and Well, just write your code here. That's it. That's this, I guess. Yeah. 1, 2, 3, 6, 9, 12. We have 12 as arguments. Let's init Raylib, so tag include raylib.h and main float one widths 800 sounds good. Let's make this 1000, make this 800. This sounds good enough. Init window, one widths, one height, animation versus wizard. Yeah. While not window should close, let's do, and when this is over, we'll close window, begin drawing, clear background, white, and drawing. Yeah. So far, so not so good actually. Let's push this to, I'm not sure what were the conventional values, but um, I'll get them later. Anyways, let's make orange actually character class character.cbb and hashtag include raylib.h class character. Yeah, we'll make constructor, what's public, private, and hashtag include character.h character column character. We will look into what we should put in each one later. But as of now, there's an important function I need, which is the render. Actually, here we must initialize through the texture. So let's get a location of which thing are we loading exactly. Let's rename this to actually player. So that's character for a player. So include player.h. Instead of this, we'll name it player, and then instead of this two, we'll name them player. Pass. Do we need something else as of now? No. Let's car pass to take a string and yep. Texture 2D texture. Let's set texture to load texture pass. We need a render function, so render returns void. We need the delta, which I forgot to do here, so set target FPS to 60, delta equal float delta get frame time. Okay, let's actually initialize the player here. Player tag include, why is there an, oh yeah, my bad. Player dot h players, oh, this is annoying. I really don't know how to solve this in VS Code. Player orange. I think it was done like this if I remember it correctly. I hope I do. Let's create definition here. So draw texture. We will need texture which we already have. Source, destination, and origin. I'll leave this empty. 0 for rotation. White, I guess. Oh, there's something actually I forgot to do here. Is this um, remove background, and let's upload this here. Download orange. Yes, could realize this now because it will be very annoying later actually to realize, you know. Anyways, where are we at? Yeah, here. Um, rectangle source. Let's draw it for now at 0 0. Temperature the temperature width divided by max frames. Temperature dot height by columns. Height divided by rows. This is divided by columns. And let's create them now. So private, no, sorry, float rows is equal to 1 2 3 4 5 6 7 8 9 10 11 12. 12 float columns is equal to 3. I flipped them accidentally. They always get me confused. Max rows, max columns, actually max columns. Yep. So rectangle, this is equal to, for the destination, which is where I'll draw it basically, I'll keep it at 0 0. I don't know. Source. Actually, let's make we'll develop width, height. Yeah, and let's define this here. So float width, float height. This way our code is like much cleaner, you know. So let's, for the destination, we'll have here width, let's have height. Time is some sort of a scale, and here time is some sort of a scale, which we're gonna add a scale. Let's keep it 1.f for now. Let's render what we have so far and see if it is working. So orange dot render was in delta, and let's see if this works. Great, it doesn't. Let's see. C++ declaring. No, I kind of forgot how it was done, to be honest. So it was done like this, right? Wait, I literally have a wrong pass here. Assets slash. Since our character is getting drawn correctly, I just think we need to increase the scale a bit more. We should center this guy in the middle of the screen, so as the initial starting location. So to do so, we need to, yeah, okay. Instead of declaring source here, we will make it here, and we will declare it like here, source, and we will have here when widths. We will make some sort of a calculation here actually. When we need to take it here, float, actually spawn x, float spawn y, yeah, and we need to spawn him exactly at this point, so we will do spawn x. So we need to add half of our widths. No. We need to subtract half of the widths actually. Wait, actually, let me get a whiteboard quickly. Here's our character, little rectangle, and this is our origin, and this is our window widths. Okay, I mean our entire window. So I will pass, hey, spawn it at the middle of our widths and make the leg stand here. So I will pass this point, and I'm expecting the character to be drawn like this, right? We'll have his legs here, his hands, and his body, and his origin is still here. So if I put him exactly at the width, he will get drawn like this, which I don't want. So I need to subtract half of our character widths, so he can be like this exactly. So minus half of our width, and we'll do the same thing for the height. If I pass the exact value, he will be here. So I need to subtract to go up. Up is positive and down is up is negative and down is positive in computer coordinating system. So we will go up by our entire character height. So spawn y minus height. This will work on centering it. He's complaining because in our header file we only get pass, while we here get overloading stuff basically. So I can press control dot and press on create declaration, and it will automatically declare it. We now need to delete the old one, and all good. Back to our main.cpp. We will pass here some extra stuff. We want to spawn him at win width divided by 2 and win height. Yeah, all win height, so he can be at the very bottom down. Okay, so there's something wrong. What is the issue? Spawn. Let me try to make a breakpoint here and send the debugger what's wrong basically. So I wanna check for source. Oh, my bad, I'm sorry. The source is the source itself of the rectangle where it gets drawn, but destination is where to draw it on the screen. So that was supposed to be for destination itself, and I need to make destination. I don't think I need to make source really. But let's initialize it here instead of having to draw it each time. So 0 0 for now, width and height. This should work perfectly now. And look at this, yay! I forgot to multiply this by scale and multiply this by scale as well. So now you should get drawn a bit bigger by scale of 2. Let's see. Oh, yeah. So spawn x minus width multiplied by 2. The issue is we are scaling him by 2, so we need to multiply width by scale, and then it will get divided by 2. Same goes for height. Height should be multiplied by scale as well. Perfect. I really like this. Now let's animate him a bit. So let's get here and make some animating variables and animating vars. And here we'll have the animating variables. So we need update time, which is a float that represents the time and we need to wait before making an update basically. So let's make it 1/12 seconds. We need running time to check if let's initialize it to 0. Actually equal 0. Let's have frame to check our current frame. It will be initialized to 0 as well. So my plan is like at 0 frame, at 1 frame, 2, 3, This is what frame is for basically. We need some variables to know where everything lies basically. So idle is for row 0. So let's open this sidebar using control backslash float idle row equal idle row float jump row equal 1 float run row equal 2. Yeah, perfect. We need as well how many frames. So idle frames is equal to 1 2 3 4 5 6 7. Jump frames is equal to 12 if I remember correctly, and run frames looks like 5. Yeah. Now in player.cpp, let's start animating. So running time, we will add delta to it. If running time is greater than or equal update time, we will animate a different thing. So how will I go with this? How would I go with this? Let's think. Source. Let's skip the as it is. Let's just do frames plus plus. Running time is equal 0. Frame, sorry. If frame, let's make a little condition. If let's keep it true for now. This will be for our idle case. If true, idle check. So frames, if frame is greater than or equal, hold up, let's see. So 0 1 2 3 4 5 6. I wanted to step here, so when frames go plus plus, it will be 7, which would be greater than or equal our total frames count. So idle frames, we do frame is equal 0, and then source dot x is equal frame multiplied by the width. This should create a simple idling animation. Yeah, perfect. Now let's handle movement. Okay, how would I go with handling movement itself? If is key down, key underscore a. If it is down, then we need to go left. We need to make a direction variable, which is vector2. Then direction dot x minus minus. We will have for condition like this. Dot d. Actually, I will key underscore left underscore arrow. Okay, let's check for arrows later. We'll increment this x here. If it is w, then we want to go up, so y minus minus. If it is s, then we will go down, so y plus plus. Direction is equal to direction. No, hold up. Let's hashtag include raylib.h first, and then hashtag include raymass.h. Where is it? Oh, my bad. No, hold up. Yeah, there. Direction is equal to vector to normalize direction. And now, if direction vector to length of direction, then so if there is direction, this means that the player is basically trying to move. For the else state, then he is idle. There is a little else if in between that checks if he is jumping, but we will ignore it as of now. So to do check jumping. Okay, let's try to run. There's nothing that's supposed to happen unless he is idling. When I press any of the movement arrows, he will stop idling as I am moving. So far so good. Now, oh, by the way, this will get the length of the vector. I can do is equal 0. I mean not equal 0 to see if I have a direction, but 0 is false, so don't have to do this, you know. Anyways, what do we have to do now? What do we have to do? We need to move the character. We need some sort of uh, we need some sort of a speed variable. So it's not in our animations. Let's initialize it here. Float speed is equal to 20. This is frames per second. So vector to add. What will we add? We will add the destination, which we're currently at, the rectangle we're currently at. We will add it to this vector2 dot scale of direction with speed. We need to multiply this by delta. No, there's something wrong, Amda. There's something wrong. If the direction, if we are trying to move, then we need to update this. So test, this is just a rectangle. Wait, our character shouldn't even be able to go those two directions. It can just go right or left. I made this for nothing, basically. Let's make this equal to vector2 scale of direction with the value of speed, okay? So this is something. We need another variable. Let's call it vector2 world position. Our position is a world, basically. And let's initialize it here. World position is equal to destination.x destination.y. Let's set world position to it, but let's add a vector to add our existing world position with a vector of value direction and scale of our speed, basically. Oh, I forgot to multiply here by delta. So this should work. I just need to do here destination.x equal world position.x and same for the y. Yeah, let's see. Okay, it's working. I need to increase the speed a bit, like make it 50, for example. I don't know. There's something else we need to change, actually. Yeah, we forgot to animate actually here. I will basically need to copy this code again, which is quite bad and inefficient. Greater than the time frames plus running time is equal 0. If this time it will be run frames. How about max frames instead? Frame is equal 0. Source screen frame multiplied by width. I need source.y is equal height multiplied by the row we want. Let's cut this code and make a function. Like under here, for example, void layer animate. So what do we need? Float max frames float row. I think this is all what we need. Yeah, this is all what we need. Now let's press here, control dot, create definition. I want it to be in the private section. All good. Now, so we will do animate. We need to pass maximum amount of frames we can have. So running, no, it's run frames. And for the row, run row. And here, instead of that, we will do animate idle frames, idle row. Good. Let's see where we're at. Oh, we hit an hour. Not good. I hope OBS doesn't do funny things, because when I record stuff is sometimes like the resolution is laggy and stuff. So I really hope this won't happen now. Anyways, I need to flip the source if he's going backward. So I need to flip him here. In order to flip him, we will check if direction.x is less than 0. So he's trying to go in the negative direction. And I must make sure that to flip a character in Raylib, I go to the source and I make the width by negative value. This will flip him. But I need to make sure that his width is not a negative value already. So, and source.width is greater than 0. We will width multiplied equal -1, right? And by that, when he goes left, his width will become less than 0, so this condition will only run once. Again, there is an issue with this. What is the issue? If direction.x is less than 0 and source.width is greater than 0, width... Oh wait, I multiplied the character width itself. I should have multiplied source.width. So this will allow me to go left, but I won't be able to go right again. So I need to configure it to be able to go right. So, or direction.x is greater than 0 and our width is less than 0. This means we're flipped, so we need to reflip him back to be in the correct position. Perfect. Now we need to allow our character to jump, basically, which we will after a little tea break, Okay, and I'm back. Let's continue editing. Before I do anything, I just want to increase the speed variable a bit. Actually, a lot. Let's make it 200. Yeah, this is much better. The guy can't jump so far, so we need to configure that. And of course, for jump, you will of course need gravity. Let's set it to 1. And we would need the velocity. Let's keep it at 0 for now. Should we allow him to double jump? At a later stage of the game, this character should fly as well, so actually let's handle this later. Let's for now do pull is in air equal false, and here let's do if is key down, key underscore space, and not is in air. What should we do? Is in air should be set to true, of course, and I should allow him to jump. So how much? Float jump power is equal to 50, and velocity is equal to negative jump power. Then I will velocity minus equal, actually plus equal, gravity multiplied by delta. Okay, and then I need to apply this velocity. So if is in air, this means he's jumping. Let's delete this. This should be an else if statement, because if he is in air, even if he is moving, the priority would be to this. And I need to take this line out so that we would change the direction he's looking at, even if he is in the air. Okay. And what else do we need to do here? Let's just do animate from jump frames, jump row. Let's test our game so far to check if it animates when we jump. Okay, and it jumps. We should do multiple things actually here. First of all, we need to check if we are grounded. So let's create ground. Draw rectangle ground. It's create at 0 0 one width, one height. No, this is one height minus 20, I guess, or something. So wait, I'm not drawing it. Draw rectangle from a rectangle. Ground, its color will be red. And here in the player, instead of making him stand on the one height, we will make him stand on ground dot y. This is an issue with how the character is drawn, so we need to go to source and of the character drawing, and we need to execute some sort of value here, so to crop him out. So let's see, let's keep him like that for now. We will figure out a solution later. Yeah, let's try to apply some gravity and check if he is grounded. So let's check the Raylib examples actually to see how they did it. So it's a simple game with some simple platforms. Okay, update player. And now we check if we pressed one of those keys. Basically, if we hit a space, and I just if not is in air, we won't run this animation, otherwise we'll place as run. And we can embed those presses out. Let's create our hit obstacles. Struct obstacle, or actually let's call it platform. So it will need a rectangle to represent it, basically. What else will it need? It will need blocking. I'm not sure what blocking stands for, but color is of course its color. And then let's create a bunch of platforms, const platform int platform len 5, for example. Actually, let's keep them 4, platform len. Then we will have We'll have this as our first rectangle. Not sure what to put in. Blocking, to be honest. Items. Wait, is this like... Oh! So this is like a boolean of whether it should block or not. But why would I need this? I don't think I even need to make this. No, I totally don't. I'll just need an array of rectangles of platform lengths, and this will be my ground, and this will be platforms of 0.y. 1 2 3 4 for auto platforms draw rectangle ground. So I'm going to just do platform, and let's keep it 1 as of now. And of course I need semicolon here, and all good to go. Platforms. Oh, let's make them all black, and let's create another one. So wait, how does this even... Oh yeah, so x position would be 0, our y position would be 1 height minus 70, our width would be 100, and we would be like 10 pixels long. So we would have 4 of these. Actually, let's make it 3 for simplicity as of now. I'm gonna make this win width minus 100. It should be at the same position. Let's make this win width divided by 2. 1 height minus 120. Let's make this 50 width, 10 pixels long. Let's see how this looks like. I want to make this minus 200. I want to make the width like 200 and make this width 100. I think this looks better. Oh no, let's make it 300 actually. And actually there's something here wrong. I need to add 100 to it. Actually subtract 100 from win width, and then when it gets divided to 2 it will be exactly at the middle, but I need to put those in brackets. So win width as middle minus 100 divided by 2. Yeah, perfect. Now let's get started on our movement itself. So let's see how they do it here. So insert function called update player. If key down, we'll move the player by delta, multiply by delta here. And we here, if he's pressing space and player can jump, which is basically our condition here, where we see if he pressed the space. So let's make this if he pressed the space, or is key down, key underscore W, and he is not in the air, so he basically can jump. We will set the velocity to be jump power or negative jump power, and is in air, we will set it to true so that he can't jump again. So what do we need? We basically need an array of all the items we can hit. So stop popping up. here, when we render our character, we can pass in the array platforms. So platforms, also in platforms lengths. That's all what we need. And now in player.h we need to configure this. So render will take an array of rectangle called platforms and an integer platforms len. Let's copy that definition here. Just we need to remove this and all good to go. All good to go. Perfect. Now we will loop through all the platforms. So for auto platforms. Oh yeah, right. This is an address. So for int I equals 0, I less than platforms len I plus rectangle platform is equal to platforms of I. Now what should we do? If ei and item, yeah, same thing basically. Vector pointer, he basically checks if they are colliding. So if rectangle check collision rex between rectangle 1 which is player destination and rectangle 2 which is the platform itself. So if a collision exists, is an error equal to false. But a collision could be from the bottom, so I need to check if the bottom of the player is greater than the top of. It's time to make a hitbox function. So void rectangle get hitbox. This takes nothing, it's just returns. As of now I will just return as this. Let's qualify it. Just returns this for the player for now. Let's make this function really quickly. Yeah. Now here we will do get hitbox rectangle player hitbox equal to get hitbox. So now we need to check if the feet of the player, so player feet basically be player hitbox dot y. So this is the top left, so we need to subtract the player hitbox dot height from it. Okay, so this is the player feet, form of integer I guess. So we need to make sure they are colliding and the player feet is above the platform dot y. So I can wait, what did I do? I can directly take this get hitbox dot y and then cut it out, put it here. So if the feet of the player is less than or equal to platform.y, so this ensures the player is basically above the platform. Is an error is equal to false. Let's see. By the way, with this, the player when he tries to jump, he will immediately get back to being in the original state. So we will run this if not is an error. Let's work on making the player actually jump. So here we will add the velocity. Gravity multiplied by delta. But if he is grounded, if he is not in air, then velocity should equal to 0, right? Or I can do it like this: is in air 0, otherwise no, not yeah, keep it like this. Now where do I apply my gravity? And here I set velocity to negative jump power. Now I just need, so do I just do it like this for the position dot y plus velocity? I'm not sure honestly, but in theory this should work. Yeah, I think I figured it out. It should be plus equal velocity multiplied by delta. This should fix it. Huh? Negative 100 multiplied by delta. Is it too slow that I can barely see it, or what is going on? I don't get. Destination.y. Second time it goes here. It should append. Why is it not adding anything? Is there a part where I... Oh. That's because of this. If I want to jump, I basically shouldn't set it to world position.y. How should I do it? We add world position itself. So we should just technically do here world position plus equal negative 100 multiplied by delta, and this should work, right? Oh, my bad. It will cause it to fly up. No, I don't want to check one so far. I think it flew up too quickly, so let's slow down this number a bit. Perfect. Velocity. I want to change this to velocity y. Yeah, apply. Velocity y. Now we'll return back the gravity. If not is in air, then velocity y would be 0. Velocity y. This is velocity in y direction. We keep adding the gravity to cause it to fall. Velocity y, we set it to negative jump power. Is in air is equal to true. If he's in air, then we check for collisions. If he's colliding and his feet is above something, then he won't be in air. And if he's not in air, then his velocity will be 0. What is happening? What happened? What just happened? It's supposed to jump up, not sink down. Plus equal velocity multiplied by delta, okay? And velocity is equal to negative jump power, so it is a negative value, and jump power is a negative value itself, so yeah. It looked quite funny. And he ascended. Okay, what the hell was that? What the hell was that? If he is not in the air, says velocity y is equal to 0. I think it seems correct. Oh, gravity is too weak. Oh yeah. Let's actually Make it like 1000, 1600 or something, I don't know. Is gravity even a thing here? Oh yeah, yeah. I think I overdid it. Let's keep this at negative 400 and keep this at 1000. No, no, 1000. I think it could compile that's a value of 100. Yeah, feels like moon literally. I'll just be playing around with them until I figure out a good value I'm happy with. So I need the jump to be a bit stronger and the fall to be a bit stronger as well. Let's try. Why is he not falling? Hello? Okay, I need to see where is the issue, so let me draw a rectangle. Let's make a quick rectangle called hitbox. As of now, I'll just set it to this, but I will change it later. Now I need to draw this rectangle, and I will return it. Background color, let's make it, is it transparent? No. No, 255, red, green, blue, and 100, actually 125. Wait, I can't quite remember is, um, what's the issue? Oh yeah, rec. The rectangle from an already existing rectangle. If I remember correctly, 255 is fully transparent. Yep. So I'll make it 125 or so. Because I wanna see. Okay, the hitbox is really big for now, right? But why is this function called only when is this function called? If I am in air, and I am in air if I'm jumping, so actually let's cut this out by the way. We wanted player feet float, yeah, so that we don't have to execute the function, this function multiple times in the loop. Anyways, this will run if we are not in the air. Let's do simple thing, draw text. We are in the air, 0050 red. So this is our issue basically, is that the player have his box way too big. So we need to reduce the hitbox. This is basically why I made this function called hitbox. So let's create a budding, which we will cut from both right and left, top and down. So of course we'll cut from the sides more than we cut from top and down. So float budding x is equal to 20. Float budding y is equal to 10. These are good numbers, I guess. Let's destination put x minus padding x. So if you are here, no, I want to add. So plus padding x, it will push it 20 pixels like this. Now we need to push it down as well. So this dot y plus padding y. Now we need to cut the width 20 here and 20 from here. So this dot width minus padding multiplied padding x multiplied by 2. Now width dot height minus padding y multiplied by 2. This should work, hopefully. I think, but I really should draw this more. Let's remove this text as it is quite useless, and let's draw it here. Get hitbox. Okay, I'm quite happy with my Y, sort of. I think I can cut it a bit down. Oh, and there is an issue with the checking here. But I will fix this. So, anyways, we need to cut the X more. So let's make it 40 and let's make the Y 15. Let's see how it ends up looking. Nope, I want it even smaller, so 50. There's something odd with how it works. If we are not in the air and velocity y is less than or equal to 0, then velocity y is equal to 0. This would... No, I mean, if we are negative, then we're going up. Yeah, we shouldn't be crashed to the ground, basically. So if we are greater than or equal to 0, then set it to 0. Keep falling until... This condition should always run. Whether we are in error or not, we should always check if we are on ground. Isn't air is equal to false and velocity is equal 0? No, if velocity y is greater than or equal 0, then velocity y is equal 0, which means we can't go down, right? So I think this fixes the issue. At least I hope. Let's restart it. Why is he not falling? Why is he not falling? Why is he not falling? He's clearly not colliding. Let's make a boolean on platform, set it initially to false and not on platform. We here, instead of setting it there, we'll set on platform is equal to true, and if velocity y is greater than 0, okay, if we are on platform is in air is equal to on platform. Does this make any difference? I don't know. Let's see. No, this is terrible. This is terrible. This should be the opposite of. So basically, we are not on any platform yet. Will it check if we are on any platform? If yes, then we will break out of this loop. But before so, we will see, is our velocity greater than or equal to 0, which means it's by negative. If it is by negative, then we'll set it to 0. Is on air should be the opposite of is. Are we on a platform or not? So I just wanna see there's something wrong with the hitbox here. It's literally falling from here. This is not correct. Why? Why is it falling? Oh, I'm an idiot. Get hitbox. I was using the test instead of our character hitbox, so that's what was causing all those issues basically. I just realized that my jumping animation is really terrible, but yeah, whatever. Anyways, I think I need to decrease this a bit, and actually 750, and let's remove the draw rectangle from here. This function, we no longer need to make a hitbox over it, so we can just return the value directly. Okay, and we're all ready to go for our next stage, which is animating the wait, what? This is quite funny bug, but I don't think I even need to fix it. It's like quite funny. Anyways, I just realized there were no point at all at doing this on platform condition. I could simply say is in air and assume it to be true, so he is in air, and while we are still in air, we will check for each platform, and if we were colliding with one of these platforms and our leg is on top of it, then is in air will be false, and so we'll break out of this, and we don't need this, and yeah, this should work perfectly fine. The next stage would be making wizard skeletons come and attack our player, and he should defend himself, which we're going to do next, hopefully. Well, now we have this little jumping Alan Becker orange guy. Now our next stage would be to make the floor lava instead of a normal ground. I want to actually test something. Through the calculations I'm doing so far, if I move this second stage, then we should spawn on the middle block first, right? Yeah, it's a bit awkward, but it's working. So we will make floor lava, and we have to jump, keep jumping. Wizard skeletons will keep throwing their swords at us, and we have to just avoid them, jump from platform to another for a specific time and avoid dying. So this would be quite fun. See you guys in the next video. Bye bye.